So now we're going to check out a couple, we're going to do some applications of these properties. So let's look at number 6 for this product property. I'll go ahead and write them down on my piece of paper here, but at the top of the page, I'm going to remind ourselves what we're working with. That is, if we have log base b of a product of two numbers, we can rewrite that as the logarithm of the same base of each of the individual numbers. That's what that product property states. So number 6a gives us log base b of 7 times 13. Well, that just becomes log base b of 7 plus log base b of 13. That's it. Letter B of number 6 gives us log base 3 of x times y times z. Now we have to assume that all three of these numbers are positive, and if one or three of them was not positive, then this would be undefined because we cannot evaluate a log of a negative number. So we'll just assume they're all positive numbers, and if they are, then we can write this as the sum of each thing. So log base 3 of x, log base 3 of y, log base 3 of z. The point here is it doesn't matter how many numbers we're multiplying together. We can rewrite them all in terms of a sum of each of the individual things. Here's a tricky one, log base 10 of 15. Now notice I did not write the log base. I didn't write the 10. That's because this is a common log. And here the tricky part is we have to recognize that 15 can be written as a product of 3 times 5. So this is log 10 of 3 plus common log of 5. You may be asking yourselves, why is that useful? Well, I don't know. It might become more useful later on. There might be cases where we can simplify things by doing this. All right, and then the last one here, note this is natural log, so ln of 3 times x times y. Sometimes students mistakenly see a 3 as somehow different than x or somehow connected to the x. Remember, all three of these are numbers. These are just letters that are standing in the place of a number that we don't currently know. So that means we turn these into a sum. So in all three of these cases, we were writing the product that was within the logarithm as a sum of two individual logarithms. So we were taking a condensed version of our property here and turning it into an expanded version or a sum. Now we're going to go backwards. So for number 7, we're told, hey, if we're given natural log of A plus natural log of B plus natural log of C, could we write that as a single logarithm? Well, most certainly. Since we're adding all three of these together and they all have the exact same base, base E, we can just rewrite this as the product of the three numbers. All right, and then one more. Here we're looking at log base 4 of 3 plus log base 4 of 9. So we can rewrite this as log base 4 of 3 times 9, or if we prefer, log base 4 of 27. Now, the result of this is not a nice number. This is we're saying 4 to what power equals 27. It's not a nice clean integer value. We'd have to use our calculator if we wanted to figure out what that number was. Okay, now we're going to switch gears. So let's go back to our data. Remember, we had 2 and 5 and 10, and these were the logarithms of each of those. So our textbook is going to say, hey, notice something about these. We're going to try to figure out what's up with a quotient. So let's try this. What is 26.75 minus 8.05? Well, if you think back to the beginning of this part, we noted that by adding these two numbers together, the 18.7 plus the 0.05, we got 26.75. So if we subtract these two, we're going to get 18.70. Now, how is that useful? How is that helpful? So let's now make the connection between these results. So recall that this was 0.75 times log of 10. This result came from doing 26.75 times log of 2, and then this one was 26.75 times log of 5. Just like before, we can divide all these by 26.75, each piece of these, because we're dividing both sides of the equation by the same thing, so we are not messing with that equality. And we get that log 10 minus log 2 is equal to, boy, you can't see what I'm writing. There we go. Log 5. Well, what's the connection between 10 and 2 and 5? If you think about before we did multiplication of these two, you could even think about adding this, and then you could do 2 times 5 is 10. Now we can show that this is really log of 10 divided by 2. So the quotient property is if we have division within our logarithm, so log of any base, call that b, of a divided by b, that's equal to log base b of, now the order we do the subtraction is very important, the numerator value minus log of the denominator value. Now we have some special restrictions on a and b. As before, a and b have to both be positive. That is still true. And really we've got the restriction here, b cannot equal 0. We couldn't have b equal 0 before, so this really isn't an extra restriction. It's just that we can't divide by 0. But we can't take logarithm of 0 either, so it's all kind of the same thing. Okay, so let's take a look at page 364, and we're going to look at numbers 9 and 10 and 11. So for number 9, 9a, we're being asked to rewrite this log base 6 of 17 divided by 3 in terms of a difference of those values. So actually, the directions say write as a sum or difference. Well, since this is just division within the logarithm, we would do log base 6 of the numerator minus log base 6 of the denominator of that expression within the logarithm. All right, and then b, we're now doing natural log of x divided by 23. Again, don't let letters intimidate you. They're just holding places for numbers. So since x is in the numerator, we're going to evaluate natural log of that x first, and then we're going to subtract what's in the denominator. All right, check out c. Here we've got log base 2 of 2x divided by y. Well, I see division here, so right away we can do log 2 of 2x minus log 2 of y. And we've taken care of the division within the logarithm. But now, in this single one, we have multiplication. Combining that product property with this quotient property, we can rewrite this one as log base 2 of 2 plus log base 2 of x minus log base 2 of y. And then we can get super excited and say, oh wait, I know what log base 2 of 2 is from before. Remember that property that said if I have log base b of b, the result is 1? So here's our final nice answer, 1 plus log 2 of x minus log 2 of y, final answer. Okay, we need a new sheet of paper, and we got one more. This is 9D. And that says, what's up with log base 3 of 2 divided by, so this is log base 10, common log of 3 divided by 2z. Well, again, we have to be very careful. Numerator minus the common log of the denominator here. And then we have a product down here, so we can rewrite this as log base 3, log 10 of 3 minus, and I have to use parentheses here because we're subtracting all of this, and when I break it into two separate parts, two separate logarithms, that negative needs to apply to both of them. So we'll distribute it and get our final answer as log 3 minus log 2 minus log z. That's an easy place to make a mistake, so watch for that. If you have a product in the denominator, that's this piece, when you apply the quotient rule and then apply the product rule, you need to be very careful that you apply that negative to both pieces.